Before there was life, before oceans shimmered blue beneath gentle skies, before a single breath ever stirred the air, there was fire. A young star burned in a violent universe, and from dust, collision, and cosmic turmoil, a world began to form. Not in silence, not in peace, but in roaring heat, molten stone and storms of metal and light. The history of the Earth did not begin with harmony. It began with sacrifice, collision, and time beyond imagination. Here, in this distant dawn, Earth was a furnace wrapped in toxic skies. Volcanoes bled oceans of magma. Meteor storms hammered the surface with relentless fury. Lightning scarred the heavens, and the moon rose not gracefully but from a cosmic wound, the scar of a collision that nearly ended the planet before it ever lived. And yet, from this chaos, foundations formed. A crust learned to hold. Water learned to fall. Chemistry learned to persist. The planet forged stability not by chance, but by persistence measured in billions of years. Welcome to Chronicles of Earth, where we follow the planet's journey from cosmic dust to living world, where every chapter reveals how time, pressure, and energy shaped everything we call home. Here, science is not cold. It breathes, it dreams, and it reminds us that even the quietest grain of sand carries the memory of fire. This episode begins at the very first page of the geological eras, the Hadean, the story before life, the age where the planet learned to exist so that life could one day rise. If you think the universe creates through softness, think again. Creation is heat, violence, adaptation. The origin of life was not peaceful, it was earned. And you are built from that resilience. Every cell in your body carries atoms forged in stars older than the cosmos you see. We don't simply study science, we witness ourselves through time. The journey ahead will take you through supervolcanoes, boiling seas, newborn moons, and the chemistry of first breath. Stay with me. The reward is perspective. Before we dive into this first era, tell me, are you ready to see how a lifeless planet carved the path for everything that ever loved, breathed, or dreamed? If this story moves you, like the deep pulse of a timeless world, subscribe to Chronicles of Earth, like this video, and share your thoughts. Your voice builds this community, and this is only the beginning. The universe wrote a masterpiece, and today we turn the first page. The birth from cosmic dust. In the beginning there was no Earth, no oceans, no sky, no cradle for life, only a restless swirl of cosmic ash drifting in the endless darkness of the universe, stirred by ancient forces older than memory. From that quiet chaos, gravity began its timeless work, pulling dust and stone together, grain by grain, breath by breath, in a slow dance that would shape the future of our planet and humanity itself. This wasn't a moment. It was a saga in the story of the cosmos. The early sun burned young and fierce, lighting the newborn solar system like a torch in a void without mercy. Surrounding it, a disk of raw material churned, fragments from dying stars, shards forged in supernova flames, the same substances that would one day breathe life into oceans and continents. Collisions were constant, violent, relentless, forging not destruction alone but creation. Every impact was a spark, a step toward the Earth we would someday call home. Piece by piece, rock joined rock, fire met fire, and the proto-Earth rose like an ember in a furnace. Temperature soared, metal melted, and molten rivers flowed across its surface in a world without water or air. This was not yet a planet, but a promise, a glowing sphere sculpted by cosmic time. As debris continued to rain, the young Earth absorbed each blow, growing heavier, stronger, more defined in the grand tapestry of geological eras. Yet creation is never gentle. Meteor storms pounded the surface, shaping mountains before mountains had names. Energy surged through every collision, leaving the surface incandescent, a world too hot for oceans, too hostile for life. Still, the foundations were forming, a core separating from mantle and crust, iron sinking inward, igniting a magnetic field that would one day shield life from the sun's unforgiving breath. Science reveals this truth. Even beauty begins with chaos. In the silence of this early time, without air to carry sound, Earth's story unfolded in blazing fire. Seas of molten rock stretched across horizons, painting landscapes that only time itself could witness. The universe built this planet slowly, not with sudden miracles, but with patience measured in billions of years. And in that patience, we glimpse our own journey, that nothing worth becoming forms overnight. The history of the Earth whispered a lesson before life ever emerged. Far beyond this fiery sphere, comets and asteroids roamed the cosmos, carrying ingredients that would later define life, oceans, and atmosphere. But for now, Earth was raw and untamed, suspended in space like a molten jewel. Every rotation around the young sun etched deeper the cycle of cosmic order. This hostile beginning holds a secret every scientist knows. Before life, there must first be structure. Before evolution, there must be foundation. As we witness this fiery dawn, we are reminded we come from dust, the same dust that built planets, stars, and our beating hearts. This stage of Earth's journey is not distant. It is our origin story, a reminder of resilience older than oceans and mountains. In understanding it, we better understand ourselves and the fragile, magnificent planet we call home. When you finish this chapter, explore our video about the birth of the solar system to continue this cosmic journey. The collision that changed everything, birth of the moon. The young Earth, glowing like a newborn ember, was not alone in this early solar system. Countless worlds struggled for space, formed by the same cosmic dust, driven by the same laws of gravity and chaos. Among them moved a Mars-sized body we now call Theia, a wandering planetesimal on a destiny-bound path. None could predict that this encounter would reshape the entire future of the planet and the very possibility of life. When Theia finally struck, it was not a simple collision. It was a cosmic cataclysm. The force of impact dwarfed any supervolcano, any extreme event humanity would ever know. Rock vaporized, planetary crust shattered, energy erupted greater than billions of nuclear blasts combined. In an instant, Earth was torn open, molten once more, suspended between annihilation and rebirth. This was destruction with purpose, violence that carved a new chapter in the history of the Earth. Fragments of both worlds were flung into orbit, glowing like sparks from a celestial forge. Gravity gathered them, weaving a ring around the wounded planet. Slowly, those fragments embraced each other, pulling close, taking shape. And from that swirling river of molten stone, a moon was born. Not by gentle crafting, but by cosmic fire and unimaginable force. The universe, it seems, builds future beauty through storms of chaos. As the moon settled into orbit, Earth began to heal. The molten surface churned under a sky of vapor and dust lit by the newborn lunar glow. The moon's presence stabilized Earth's spin, setting the rhythm that would later shape tides, seasons, climate, foundations necessary for oceans and eventually life. Without that collision, we would not exist. The origin of life on this planet is tied not to peace but to collision and transformation. Each night when we look up, we're seeing a relic of that ancient impact, a companion born from Earth itself. The moon is more than rock and dust. It's memory, a silent witness to every geological era that would follow. It guided the tides, influenced early oceans, and shaped biological rhythms. Humanity would someday navigate by its light, dream beneath its glow, and send explorers across its silent surface. But in this era, it was simply beginning its eternal dance. Back then, Earth spun faster, days shorter, nights fleeting, while molten seas bubbled beneath toxic skies. No oceans yet, no atmosphere fit to breathe, only a world cooling from cosmic fire. But balance was forming. Gravity calmed, heat began to radiate outward, and the moon pulled the planet toward stability, its gravitational embrace shaping the destiny of continents and creatures not yet imagined. Science shows that even chaos bows to natural laws with time. So as our planet and moon settled into motion, the stage was set for the next chapter, the long cooling, the first crust, the early atmosphere born from fire. When you're ready to step deeper into this cosmic origin, explore our future episode on how the moon shapes life on Earth, a story that continues long after this ancient collision. But here in the Hadean, we witness a truth. Creation demands courage and worlds are forged through fire. A planet of fire, the molten Hadean surface. Imagine standing where no life could ever stand, on the surface of the newborn Earth, 4.5 billion years ago. There is no soil beneath your feet, no wind brushing against your skin, no sky as we know it. Instead, a sea of molten rock stretches as far as vision can reach, glowing with the furious pulse of a world still in the making. This is a planet defined not by peace, but by relentless heat, a furnace suspended within the cosmos. Volcanoes rise and collapse in a constant cycle of eruption and rebirth, pouring rivers of lava across a crust too young to rest. Supervolcanoes explode not once every 1,000 years, but continuously, reshaping the land with terrifying power. Here, the history of the Earth is written in fire. There are no oceans to cool the land, no quiet valleys or mountains yet softened by time, only raw fury sculpting a foundation for what future life will one day require. Above this inferno hangs a sky thick with vapor and ash, illuminated by the glow of molten plains below and the young moon beyond. Lightning rips through the darkness, fueled by violent chemistry in the early atmosphere. Meteorites still rain from the cosmos, striking with the force of forgotten worlds. In this extreme environment, every moment threatens to erase what was just created. Yet each moment also builds what will eventually endure. The universe demands resilience even before life exists. The surface churns like a living thing, metal and stone constantly shifting, sinking, rising. Deep within, the core forms, spinning, generating a magnetic field that shields Earth from solar winds that could strip away any future chance for oceans or air. Even in its earliest days, this planet fought to preserve its destiny, a testament to natural laws that favor structure, balance, and the improbable emergence of life. Science doesn't offer miracles, it offers process, patience, and awe. No human eyes witness this era, but through geology and physics we trace its scars and echoes. Ancient minerals found in forgotten zircon crystals whisper of liquid water attempting to condense, only to evaporate again in the planet's heat. The crust tries to solidify, only to melt under relentless bombardment. Yet in this struggle, we see the cosmic beginning of continents, oceans, and climates. Earth was not always a blue world. It first burned red and gold like a star's discarded ember. To observe this world is to feel small, humbled by the scale of time and force. Before humanity, before life, before even the atmosphere that nurtures us, there was only raw creation. And yet this fiery stage is not the end, and it's the first act, the foundation for the planet we call home. When this molten age finally begins to cool, something extraordinary will follow. In another episode, explore when Earth's first oceans formed to see how water would transform this hostile surface. This chapter reminds us that beginnings are rarely gentle. Growth often rises from turmoil and beauty from chaos. Like the Earth, we evolve through heat and pressure, finding strength in adversity. And here in the Hadean furnace, the future waited. Oceans unborn, continents unshaped, life merely a possibility. A toxic shroud. The birth of the first atmosphere. The molten planet slowly exhaled, and from its blazing wounds rose the earliest atmosphere. Not the gentle sky we now breathe, but a suffocating veil of toxic gases. Steam hissed from volcanic cracks, carbon dioxide filled the heavens, and clouds of sulfur choked the air. There was no blue above, no sunlight breaking cleanly through. Instead, a dense, poisonous blanket wrapped the Earth, sealing it in heat and shadow. This was not yet a world for life, but the stage where life's conditions first began to gather. Volcanic plumes towered like mountains of smoke, releasing methane, ammonia, and nitrogen into the growing sky. Every eruption reshaped the balance of gases, sculpting a chaotic chemical symphony. With each violent pulse, Earth pushed toward stability, though it seemed in these early moments forever trapped in fire and fumes. Had you tried to breathe here, your lungs would have burned within seconds. Yet paradoxically, everything life would one day need was slowly assembling in the darkness. Lightning split the clouds, igniting chemical reactions across the atmosphere's turbulent layers. These storms weren't mere displays of power, they were engines of transformation, breaking molecules apart and forging new ones. Above the glowing seas of lava, complex compounds began to stir, like whispers of possibility hidden in the poison. Though no oceans yet pooled on the surface, vapor swirled, waiting for a future where temperatures would fall and the planet would cool enough to cradle liquid water. Science traces these clues in ancient rocks and isotopes, evidence of a world preparing itself long before life arrived. The solar winds battered this fragile atmosphere, threatening to tear it apart. But deep inside the young Earth, the molten core churned, generating a magnetic field, an invisible shield against cosmic violence. Without it, the sun would have stripped this newborn sky away. With it, Earth held on. In this era of extremes, survival itself was an act of defiance against the universe. Planets without such protection would remain barren. Ours endured, and that endurance would change everything that followed. Slowly, the atmosphere thickened. Pressure rose. Temperatures fluctuated but gradually cooled. Still toxic, still deadly yet increasingly stable, the sky transformed from chaos into order. No oceans yet rolled beneath it. No continents broke the surface, but foundations were set. When water eventually condensed and rained, not for hours but for thousands of years, that same atmosphere would hold it close, birthing the first seas. These early gases, once destructive, would one day become life's breath and shield. From this hostile sky, a lesson emerges. Transformation rarely begins in comfort. Sometimes the future is forged in conditions that seem impossible to survive. Earth didn't begin as a paradise. It earned its beauty through ages of change, pressure, and time. And here, under a sky filled with poison and fire, the planet prepared for its next leap, the long cooling that would welcome water, oceans, and the earliest seeds of life. When you finish this chapter, visit our episode, How Earth's Atmosphere Evolved Through Time, to follow this transformation into the breathable world we know today, when the fire began to calm, the first breath of cooling. There comes a moment in every fiery creation when the blaze must learn to soften. For Earth, this shift was not sudden, but a slow surrender. Molten rivers gradually dimming, volcanic oceans clenching into solid crust. The planet still glowed with heat from within, but the fury began to settle. What was once constant eruption turned into rhythmic pulses, and the young world took its first step toward becoming a place where oceans could dream of forming. Cooling is not weakness, it is preparation. Even as temperatures dropped, the surface remained a dangerous sea of magma, crust forming only to crack apart again under internal pressure. Yet with each attempt, the solid layers lasted a little longer. Islands of rock, proto-continents, emerged briefly before sinking back into molten depths. This fragile crust was a promise that one day continents would rise and endure. And in this fragile balance of heat and solidification, the foundations of geology were born. Above, the toxic sky thickened and swirled, still deadly but now heavy with water vapor waiting for the right moment. As lightning danced across sulfurous clouds, chemical reactions multiplied, setting the stage for oceans and atmospheres far in the future. The Earth no longer burned alone in silent fire. It simmered, hissed, and cooled under the watch of its newborn moon, each rotation lengthening slightly as tidal forces slowed the planet's spin. Time moved patiently, sculpting destiny atom by atom. The crust beneath this world was unstable, constantly fractured by internal heat and external bombardment. But slowly, a pattern emerged. Heat flowed outward, minerals crystallized and layers formed. The core spun faster, strengthening the magnetic field, and the mantle churned beneath. Science reveals this era through the oldest minerals on Earth, tiny zircon crystals that whisper of a world trying to settle long before life existed. These relics prove cooling was underway far earlier than once believed. Cooling did not make Earth peaceful, it made Earth possible. While fire forged the planet, it was the gradual loss of heat that created room for transformation. Every degree that fell brought the world closer to water, weather, and eventually life. The molten surface that once glared like a star began to fade into darkness, punctuated by glowing lava seas. What looked like decline was, in truth, evolution, the universe preparing Earth not for destruction but for growth. We often imagine beginnings as eruptions of energy, yet this chapter reminds us that creation also requires calm, stillness, and the quiet persistence of time. Before there were mountains or oceans, Earth learned to cool. Before life could breathe, the planet had to rest. In this moment of cosmic patience, we glimpse our own journey, that growth demands not only fire, but also the courage to transform, slow down, and endure. The first fragile crust, Earth's earliest skin. As Earth continued to cool, a thin crust began to stretch across its molten surface, a fragile shell over a restless heart. It cracked, shifted, and melted repeatedly, unable yet to withstand the planet's blazing inner heat. But each brief layer left a mark, and each collapse taught the planet to hold together a little longer. This was geology in its infancy, the first attempt at building the foundation on which continents and life would eventually rise. These early crustal fragments were nothing like the continents we know today. They were small, volcanic, unstable, floating like broken rafts atop a sea of magma. Silicate minerals crystallized from molten rock, hardening into the first solid stones. When they fractured, lava surged through, rebuilding the surface again and again. And still the crust returned, stubborn and persistent, demonstrating the same resilience that would later shape mountains, valleys, and coastlines. Inside the planet, convection currents churned relentlessly. Heat escaped from the core and mantle, but not evenly, pushing and pulling the crust above like a pot of boiling stone. This constant movement was the precursor to what we would one day call plate tectonics. Though continents did not yet drift and collide as they will later in Earth's history, here we witness the birth of their driving force, the restless engine beneath our feet, alive with geological power. The Moon's gravitational pull helped stabilize this young surface, slowing Earth's rotation and calming some of its violent spin. Day by day, the planet's cycle lengthened, giving time room to deepen its work. The tides of molten rock responded to lunar tug, subtly shaping the crust's behavior. Even then, long before life breathed or water flowed freely, Earth and Moon danced in partnership, a cosmic choreography that still defines our world. Evidence of this primordial crust survives today in tiny crystals older than any mountain, river, or ocean, zircon grains found in ancient rocks. These microscopic survivors tell us that Earth's surface hardened earlier than once imagined, hinting that the seeds of stability existed even amid chaos. Through them, science reaches backward across billions of years, uncovering a world that could not yet support life, but was already making room for it. From these thin, trembling plates of stone came the first whisper of structure. The planet was learning to build, layer by layer, break by break. Every fracture was part of progress. Every failure made the crust stronger for what would follow. As we witness this stage, we see a truth mirrored in nature and in ourselves. Beginnings are rarely perfect, but persistence turns fragility into strength. The late, heavy bombardment. A sky of fire and stone. Just as the young Earth began to steady itself, the universe tested its resolve once more. Around 4.1 to 3.8 billion years ago, the sky ignited with a storm unlike anything that would ever follow. Asteroids, comets, and planetary debris hurled across the solar system, turning space into a battlefield of ancient stone and shattered worlds. Scientists call this era the Late Heavy Bombardment, a cosmic barrage that scarred planets, carved craters, and nearly erased Earth's early progress. Meteor after meteor slammed into the surface, their impacts so violent they vaporized rock, boiled seas of magma, and blasted molten materials into orbit. Entire regions of crust melted back into glowing oceans of lava, undoing millions of years of fragile stability. This wasn't a single event, it was a relentless rain of fire lasting hundreds of millions of years. In that time, the planet became a canvas of collisions, battered again and again by the raw power of the cosmos. The Moon still carries the memory of this era, its surface marked with craters that never healed. Earth, however, hides most of its wounds beneath younger rock and endless geological change. But traces remain: chemical signatures in ancient minerals, lunar samples revealing the timeline of bombardment, and the absence of preserved crust older than this catastrophe. Our planet survived because it is restless, its surface constantly renewing. Even destruction could not stop its story from unfolding. These impacts didn't only bring devastation, they also delivered building blocks. Comets carried water and organic compounds, seeds of oceans and chemistry that would later spark life. Iron-rich asteroids helped shape Earth's core and magnetic shield. Some collisions may have created temporary steam atmospheres, others deepened the crust or stirred the mantle. In chaos there was construction, in fire ingredients gathered. Nature doesn't waste even its most violent moments. For long stretches of time, the skies glowed red from molten ejecta dust and volcanic ash. Lightning split clouds saturated with heavy metals and vaporized rock. The atmosphere roared with heat, but through this crucible, Earth learned to endure. When the last great impacts faded and silence finally returned, the planet emerged changed, stronger, thicker, ready for oceans, weather, and eventually life. Survivorship was written into its very core. We often imagine stability as peace, but the history of the Earth teaches otherwise. True stability is earned, forged through upheaval and patience, measured in geological eras. From this age of fire and stone, Earth stepped into a new chapter, where water would finally fall and gather. If you wish to see how this cosmic storm shaped the potential for life, watch our upcoming episode on Comets, Carriers of Life Across the Cosmos. The First Whispers of Water. A planet begins to cool enough for rain. As the last echoes of cosmic bombardment faded, Earth exhaled again, this time not in fire, but in vapor. Temperatures slowly fell, and steam that had once boiled off molten plains began to linger in the air. Clouds thickened across the sky, not white and gentle, but dark, heavy, and filled with the memory of volcanic breath. This planet, once a furnace, now trembled on the edge of transformation. Water, the element that would one day cradle life, hovered above a world still learning to rest. It didn't happen in a single storm. It happened over millions of years, a long cooling, an ancient patience. The atmosphere remained toxic, thick with carbon dioxide, methane, and sulfur compounds. But where fire had ruled, condensation began to reign. Droplets formed, fell, evaporated on contact with scorching ground, and rose again. In that cycle, the planet rehearsed the birth of oceans. Every failed rain was a promise that one day it would succeed. Eventually, the surface cooled just enough, and the first raindrops survived the fall. Not minutes of rain, not days, but torrential downpours lasting thousands, perhaps millions of years. The sound would have been deafening, steam hissing against cooling rock, volcanic fissures drowning beneath water, newborn seas boiling at their edges. The planet that once glowed with molten light now thundered under endless storm clouds. In that roar, life's stage was being set. With each downpour, minerals dissolved, chemical reactions sparked, and new molecules formed as water carved the first scars into rock. The earliest oceans were not blue and inviting. They were acidic, hot, and heavy with dissolved iron and silica. Yet they were oceans nonetheless, pools of potential, mirrors for the young moon and restless sky. If Earth were a book, this was the moment the first blank pages became writable, the canvas for the origin of life. These waters didn't arrive only from rain. Some came from comets and asteroids, icy wanderers that once slammed into the surface. Others came from deep within, released by volcanic outgassing as the mantle breathed water into the world. Every droplet, external or internal, became part of a greater whole, the beginning of a hydrosphere. Science, geology, and cosmic chemistry converge here. The oceans were written into Earth long before life touched them. In this moment, Earth stepped closer to becoming a living world. Water, the solvent of time, the sculptor of stone, the cradle of biology, had found a home. And as oceans pooled, cooling land and shaping atmosphere, the first conditions for chemistry of life emerged. We were still billions of years away from humanity, but the path had begun. When you wish to explore this transition further, watch our future episode, The First Oceans, When Water Met Rock and Life Found a Chance. The dance of balance, rotation, tides, and a planet, finding rhythm, with oceans now gathering across its restless surface, Earth entered a new phase of cosmic choreography. The moon, born of violence yet now a guardian, tugged at the forming seas and atmosphere, slowing the planet's frantic spin. Days lengthened beyond the brief hours of the Hadean dawn, and with each rotation, stability deepened. For the first time, Earth began to move not in chaos but in rhythm, a celestial heartbeat setting pace for all future life. Early tides surged across young coastlines, far more intense than those we know today. The moon hung closer in the sky, its pull powerful, shaping currents even in oceans that still steamed with volcanic heat. These tides stirred minerals, mixed waters, and carved the first basins. They set motion into what would one day become circulation systems, patterns that guide climate, weather, and ecosystems. Even now, every wave that breaks remembers this ancient dance. The stabilization of Earth's rotation did more than shape tides, it shaped time itself. Longer days meant more sustained exposure to the sun, allowing temperatures to fluctuate less wildly and helping the atmosphere evolve. Seasons were primitive, barely beginning to form, but the seeds of climate patterns were planted. This world was learning balance, not perfect, not gentle, but a shift toward conditions life could someday endure. Science sees this not as miracle, but as necessity. A planet cannot remain wild forever if life is to emerge. Meanwhile, deep inside Earth, the liquid core spun fiercely, strengthening the magnetic field that shielded the planet from solar wind. This protective barrier kept the atmosphere from being stripped away like those of Mars or Mercury. In a universe of radiation and silence, Earth alone held breath, safeguarding the future. Without this invisible armor, oceans would have vaporized, air would have thinned, and life would never have risen from the tides. This era marks the quiet triumph of gravity, rotation, and orbital mechanics. Nothing dramatic at first glance, no firestorms, no cosmic collisions, yet these subtle shifts carried more power than any eruption. Balance is rarely loud, often it whispers. The cosmos had given Earth chaos to spark creation, and now it gave silence to nurture it. Planet and moon locked into harmony, a partnership that endures through every geological era and every chapter of life's unfolding. What we learn here echoes far beyond science. Creation requires both force and stillness, both storm and calm. Just as continents would later drift and mountains rise, Earth itself first needed to settle. Through this cosmic balance, oceans could deepen, chemistry could stir, and time could breathe. If you'd like to explore this celestial partnership further, watch our upcoming feature, If the Moon Vanished, the Fate of Earth Without Its Silent Guardian. The first stones, crystals, ancient rocks, and the memory of a young world. Long before mountains towered or continents stretched across oceans, the first minerals began to crystallize beneath Earth's cooling skin. Tiny structures formed in silence, microscopic blueprints of a planet learning solidity after ages of fire. Zircons, the oldest minerals we know, locked in chemical memories of a world still hostile, their atomic patterns whispering of heat, steam, and the first touches of liquid water. These crystals are Earth's earliest storytellers, older than any ocean, older than any land we stand on today. As magma slowly hardened into rock, the first fragments of crust thickened. Granite-like rocks shimmered beneath volcanic haze, only to be shattered again by impacts or swallowed into molten depths. Yet each cycle left pieces behind, traces of land resisting destruction. This was not yet the Earth of rolling plains and deep oceans. It was a fractured mosaic of young stone, fragile and temporary. But it was enough. Geology was awake and the planet had begun to keep its own record. The chemistry of these primitive minerals reveals a world in transition, one foot still in fire, the other stepping into water. Oxygen levels remained low, the atmosphere toxic, yet the building blocks for change accumulated layer by layer. Silicates formed the skeletons of early crust. Iron and nickel anchored the core, carbon dissolved into early seas. Nothing yet lived, but the ingredients for life gathered like actors waiting behind a curtain, preparing for a play billions of years long. These first stones teach us that even the smallest structures can carry immense purpose. Some crystals survived billions of years of erosion, pressure, and heat, tiny survivors older than any fossil, any river, any mountain. Their endurance outlives civilizations, continents, and species. When scientists hold a zircon in hand, they hold a piece of the planet as it was when the Earth was young, when oceans had barely begun to breathe and life was not yet a whisper in the dark. Rocks are often seen as symbols of stillness, yet in these early days they represented movement, cycles of creation and destruction, melting and formation. They marked the slow organization of chaos into structure, the beginning of continents that would one day support forests, deserts, and cities. Through them, Earth rehearsed permanence, practicing stability long before life required it. They were the quiet architects of future biology, chemistry, and climate. In this chapter, we honor the humble beginnings of the solid world beneath our feet. Before bones, before shells, before any living cell, came stone, the silent foundation of life's future. If you want to explore how minerals shaped evolution and ecosystems across geological eras, watch our episode How Rocks Built Life, the Hidden Chemistry of Earth's Skeleton. Oceans in Fury, Hydrothermal Worlds and Chemistry Awakening. The newborn oceans were nothing like the calm blue expanses we know today. They simmered beneath a shroud of toxic air, heavy with iron and minerals drawn from volcanic rock. Steam curled above their surface, and waters churned with heat from a restless mantle below. Deep vents split the seafloor, spewing superheated fluids into the dark, creating vast clouds of metal-rich chemistry. Here, in this violent cradle, the ocean was not a refuge yet. It was a laboratory where elements learned to collide, react, and transform. Along volcanic ridges, hydrothermal vents roared like underwater geysers, mixing scalding fluids with cooling seawater. Minerals precipitated in black plumes, forming towering chimney-like structures of iron and sulfur compounds. Pressure crushed everything, temperatures swung wildly, and acidity etched stone like sculptors' tools. And yet, in this world of extremes, chemistry awakened. Molecules collided in patterns complex enough to hint at what life might someday require: gradients, reactions, energy, and persistence. These ancient seas were threaded with dissolved metals, lightning-charged compounds from above, and volcanic gases bubbling from below. Organic molecules, carbon chains, amino-like seeds, simple precursors, began to appear not as life, but as the first whispers of possibility. In every droplet, billions of reactions unfolded, guided only by physics and time. The universe does not rush creation. It allows chaos to refine itself, molecule by molecule, cycle by cycle. This was alchemy without myth, pure chemistry in service of future biology. As ocean floors solidified and tectonic cycles grew more organized, deep-sea vents created stable gradients of heat and chemistry. Energy moved like breath, from hot to cold, sparking reactions that assembled complex structures from simple parts. Iron-sulfur minerals formed honeycomb surfaces, natural scaffolds where molecules adhered, arranged, and bonded. In these tiny chambers, protected from radiation and chaos above, early Earth rehearsed the architecture of cells long before cells existed. Meanwhile, surface waters boiled beneath a brutal sky. Ultraviolet radiation hammered the waves, breaking some molecules apart while forging others in its wake. Storms lashed the oceans, stirring chemistry in endless cycles. Nothing here resembled life, not yet, but the rules were forming. Catalysts emerged. Carbon chains grew longer. Patterns repeated. The planet was not producing life, but it was producing conditions, the rarest gift in the cosmos. And those conditions were narrowing toward the improbable. We look back at this time not with fear, but with awe. The earliest oceans were crucibles, shaping the chemistry that would become biology, sculpting the future in boiling darkness. Without this era of hydrothermal turbulence and molecular ambition, life could never have emerged. If you'd like to dive deeper into this mysterious frontier, watch our upcoming episode, Hydrothermal Origins, where chemistry learned to breathe. Pre-biotic alchemy, when molecules learned to dream. Before life began, there was instruction, written not in DNA, but in energy, chemistry, and time. Deep within the oceans, in tidal pools, and across lightning-lit skies, simple molecules began to link, fold, and react in ways that hinted at purpose. They were not alive, not conscious, not aware. Yet they behaved with patterns that would one day define life: replication, compartmentalization, and metabolism. This was the quiet revolution of prebiotic chemistry, the moment Earth began to whisper the idea of life into existence. In volcanic pools near the shoreline, wet-dry cycles concentrated organic compounds, forcing molecules together like pages being pressed into a book. Heat and minerals acted as catalysts, binding amino acids into chains, forming primitive peptides. Meanwhile, clays and silicates served as scaffolds, aligning molecules into organized arrangements, the first step toward structure. Each pattern was fragile. Each breakthrough dissolved and formed again. But repetition isn't failure. It's learning. Earth was practicing. In the depths, hydrothermal vents fueled another path. There, iron-sulfur minerals formed lattice structures that held carbon compounds in place, encouraging chemical reactions that converted raw energy into usable gradients. These vents created environments with boundaries, natural chambers where chemistry stayed, contained long enough to grow complex. Membrane-like bubbles of fat molecules formed in turbulent waters, briefly separating inside from outside, a precursor to the cell. No blueprint, just possibility refining itself. Above the oceans, storms raged, lightning flashed. Ultraviolet rays split atmospheric gases, forging hydrogen cyanide, formaldehyde, and other precursors essential to life. These chemicals fell back to sea in rain and ash, enriching the oceans and feeding early reactions. Science has shown that under these harsh conditions, nucleotides, the building blocks of RNA, can form. Molecule by molecule, Earth assembled an alphabet before writing its first biological word. At some point, not a moment, but a span of millions of years, molecules began to store information. RNA-like structures appeared, capable of copying parts of themselves, though imperfectly. Those imperfections were not flaws. They were evolution's first spark. In the turbulent chemistry of the Hadean world, chance met repetition, and repetition birthed innovation. The planet was not alive yet, but the boundary between chemistry and biology had begun to blur. What we witness here challenges imagination. Life did not arrive suddenly. It grew from patience, pressure, and persistence. The cosmos didn't hand Earth life. Earth learned life. And in this learning, we see a truth older than humanity. Change begins long before it's visible. Seeds form long before they sprout. If you're ready to explore how these chemical dreams became the first true cells, stay tuned for our episode, RNA World, when information first learned to survive. Proto-life emerges, the threshold between chemistry and being. There comes a point in the planet's long story when chemistry begins to resemble intention, when reactions no longer scatter into chaos, but cycle, repeat, and refine. In the Hadean seas, somewhere in the dark embrace of mineral chimneys or the warm rhythms of tidal pools, simple molecules assembled into self-sustaining systems. Not yet life as we know it, but the first true lean toward it. Protocells, bound by fragile membranes, powered by primitive reactions, learning to survive by trial and error across geological eras. These tiny structures trapped chemicals inside thin walls of lipids, creating safe havens from the tumult outside. Inside, reactions circulated like breath, fueled by gradients of heat and minerals. Outside, the ocean roared, storms cracked the sky, and supervolcanoes reshaped the planet. The first protocells had no eyes, no awareness, no destiny. Yet they endured. They didn't live, but they persisted. And persistence in deep time is the closest thing to instinct the early planet knew. In those silent oceans, strands of RNA-like molecules found shelter within these membranes. Some strands copied parts of themselves, clumsily and imperfectly. Some broke apart. Some remained stable long enough to influence their surroundings. That instability, that trial and error existence, became the first engine of selection. The cosmos didn't choose perfection, it chose persistence. And in that persistence, life's architecture began to take shape. Mineral surfaces served as teachers. They held molecules close, guiding them into patterns and catalyzing reactions. Inside bubbles of fat and clay, reactions grew more complex, some consuming resources from outside, others producing energy or new molecules. In this dance of structure and randomness, the line between non-living and almost alive softened. Cells would one day inherit this rhythm: metabolism, boundary, replication. But here, those principles were learning to breathe. The oceans were still hostile, the air toxic, the climate a storm of extremes. Yet these microscopic pioneers continued their silent work, slowly refining a system that could not yet call itself life. Time was their ally. Millions of years passed as experiments unfolded molecule by molecule. Most failed, a few survived. Those few carried the first spark that would, over eons, ignite biology. Even in the harshest world imaginable, the planet refused stagnation. Motion meant possibility. When we think of the origin of life, we imagine miracles. But the truth is more powerful. Life came not from magic, but from patience. It was not gifted, it was earned. If you'd like to follow how these protocells crossed the final threshold into true life during the Archean Eon, be sure to watch our episode, The First Cell When Earth Finally Woke Up. From chaos to dawn, cooling seas and the edge of the Archean, the world that began as fire was now wrapped in water and stone. Steam that once screamed from volcanic wounds settled into mist, and mist into clouds, and clouds into rain. Long, endless rain that fed newborn oceans. The planet cooled to a point where volcanic fury no longer ruled every horizon, though eruptions still punctuated the silence. In pockets between violence, calm finally emerged. For the first time, Earth knew pauses, moments where oceans lay still enough to mirror the rising moon. Continents, still small and unstable, began to root themselves in the crust. Granite-like shield rocks thickened, resisting the constant recycling into magma. These early proto-continents floated like rafts across a restless mantle, sometimes tearing apart, sometimes merging. With each collision and separation, the blueprint for modern plate tectonics strengthened. The Earth had learned destruction in its earliest ages. Now it was learning permanence. Oceans continued to gather minerals, thickening into chemical soups enriched by volcanic vents and lightning-filled skies. Iron swirled in high concentration, giving the water a deep metallic hue. Silica, sulfur, and carbon drifted through currents, settling into sediments that would become some of the oldest rocks we know. These were not yet seas that life could swim, but they were seas where life could imagine itself, where building blocks found balance and structure. Above, the sky still bore the scars of youth, rich in carbon dioxide and methane, tinted by volcanic gases. The air was heavy and warm, clouds thick and persistent, yet sunlight filtered through more gently than before, and ultraviolet radiation softened beneath a thickening atmospheric shield. Day and night cycled with newfound rhythm. Climate found patterns, heat found equilibrium. Chaos gave way to order, not through miracle, but through persistence across time deeper than imagination. Hydrothermal vents remained the pulse of chemical evolution, but now tidal pools, shorelines, and shallow basins joined them as arenas of possibility. Molecules concentrated in drying pools, bonded, and were swept back into oceans where they met different conditions. A planetary laboratory working on every surface, every second. Earth, once too hot for stability, now offered environments with gradients of temperature, chemistry, and energy. Diversity of place meant diversity of reaction, the foundation of evolution. We stand here at the threshold, the end of the Hadean, the beginning of the Archean. A planet that once raged with fire now whispered with water. A sky that once suffocated now sheltered potential. A crust that once crumbled now held continents in its arms. No creatures yet walked this world, but the stage for life was set with a patience only the universe understands. If you wish to travel into this next age, watch our upcoming chapter Archean Dawn, when Earth took its first living breath. The final breath of the Hadean, foundations beneath forever. As the last shadows of the Hadean faded, Earth stood transformed, no longer a world of molten fury, but a planet tempered by time and endurance. The crust held firm beneath newborn oceans. The atmosphere thickened into a blanket, capable of protecting and nurturing rather than only destroying. The molten heart at the planet's core spun tirelessly, guarding the sky from the sun's relentless wind. From chaos, a world capable of hosting life had emerged. The planet inhaled heat, exhaled oceans, and settled into rhythm. Nothing during this eon resembled life. yet every moment prepared for it. Minerals formed scaffolds for future chemistry. Tides sculpted coastlines for future ecosystems. Lightning charged atmosphere and water with energy. Hydrothermal vents fostered reactions that rehearsed biology. Gravity steadied rotation. Magnetic fields held the atmosphere close and oceans cooled into liquid memory. This era left no fossils, only evidence etched in zircon crystals, iron-rich rocks, and the chemical echoes of ancient waters. Silence ruled the land, but it was not emptiness, it was potential. Every atom had moved, collided, bonded, dissolved, and formed again. Billions of years passed with the planet practicing balance, structure, and cycles. Night after night, the moon watched a restless surface settle, its reflection shimmering in oceans that remembered fire. Where violence once reigned alone, harmony now coexisted with power. The Hadean was not a beginning of life. It was the beginning of the possibility of life. Through patience incomprehensible to human experience, Earth sharpened the tools of existence: stability, water, chemical gradients, and protection. The universe gives no shortcuts. The cosmos demands time to sculpt what is extraordinary. Before the first cell split, before a single breath was drawn, before sunlight nurtured a leaf or fin carved waves, the planet learned what life would need long before life arrived to claim it. We often celebrate what grows, but rarely honor what prepares the soil. The Hadean reminds us that beginnings are not always visible. They simmer beneath surfaces, hidden, relentless, essential. Progress is not always life blooming. Sometimes it is heat falling, crust forming, oceans cooling. Sometimes it is survival with no witness. The greatest chapters of existence do not seek applause. They simply build quietly and faithfully for what comes next. And so the world crossed a threshold, into the Archean, into the age of first life, into the era where chemistry finally breathed. But the Hadean remains the foundation beneath every ocean, mountain, forest, and star we ever dream under. Without fire, there is no warmth. Without chaos, no order. Without patience, no existence. When a world learned to become a home from cosmic dust to molten oceans, from collision to cooling seas, the Hadean was not merely an era, it was initiation. A world earned its right to exist. Fire did not destroy, it prepared. Chaos did not end, it shaped. In the silence before life, the planet laid every foundation life would ever need: water, crust, atmosphere, chemistry, protection, time. Nothing lived, yet everything was being readied for life's arrival. And now, as we leave this first ancient chapter and step toward the Archean, we carry a lesson written in magma and starlight. Transformation demands patience. No ocean forms in a moment. No life begins in comfort. Every great story starts in fire, and only persists because it refuses to fade. The earth did not rush. It endured. It learned to cool, to hold water, to shelter fragile molecules until they could dream of becoming cells. In its silence, it practiced life long before life answered. So now I ask you, what beginnings in your life are still hidden beneath the surface? Where is your own fire forging a future you cannot yet see? Reflect in the comments. Your voice enriches this journey. We're not just watching history, we're living by its truths. If this journey expanded your perspective, don't leave without taking part in our mission. Subscribe to Chronicles of Earth, activate the notifications, and walk with us through the ages. Each era offers new answers, each chapter, new questions. And together we trace the origin of life, the rise of continents, the battles of ice and fire, and the fragile thread that leads from the first cell to us. As Carl Sagan once said, we are a way for the universe to know itself. And it all began here, in fire, darkness, and patient light.